In the last video, the car already looked pretty stable. It could stand still, it could sit on the ground, and it did not instantly shake, slide, or drift away. But there was one important detail I did not explain yet. Why does the car stay so smooth when it is almost not moving? First, let me show the problem. Here, the vehicle is using the same suspension setup, the same raycasts, and the same basic tire model. But one part is disabled. The tire response is applied instantly. Every physics step, the script measures the current slip, then it looks up the target grip value, and then it applies that value directly. At first, this sounds correct, but at very low speed, this can become a problem. When the car is standing on a slope, gravity tries to pull it downhill, the tire model reacts immediately, the next physics step reacts again, and the step after that reacts again. So the wheel keeps fighting tiny changes in movement. The result is not smooth. The car starts to jitter. Sometimes it feels stuck, and sometimes it starts to slide in a way that does not feel natural. For a long time, I tried to fix this with stronger friction, different curves, and more counterforces. But that was not the real solution. The important fix was to give the tire force a short memory. Instead of applying the full target grip immediately, I let the current grip value move toward the target over time. The script still measures slip in the same way. It still calculates a longitudinal slip target and a lateral slip target. But with integration enabled, the current force does not jump directly to that target. It blends toward it over multiple FixedUpdate steps. This means the tire response keeps part of the previous frame. It does not reset completely every physics step. That small amount of memory makes the grip feel less digital and more physical. You can think of it as a simple tire relaxation model. A real tire does not create the full contact force instantly. The rubber deforms, the contact patch loads up, and the force builds over a short amount of time. This is what I try to approximate here. At very low slip speed, the response is soft, the grip builds up slowly. This gives gravity enough time to start the downhill motion naturally. Then, when the wheel really starts to move, the tire response catches up. Without integration, the tire force snaps to the target every frame. With integration, the force has a small delay, and that delay makes the low-speed behavior much more stable. Now the car can rest on a slope without fighting itself every frame. In the last video, we already discussed this part of the suspension script, but now one important thing has changed. The tire response is no longer applied instantly. At the top, I store the current longitudinal and lateral slip values. These are not just temporary results anymore. With integration enabled, they become the memory of the tire force. First, the script calculates the wheel movement, the contact velocity, and the slip ratios. This part still works the same as before. Then the slip curves are evaluated. They give me the target grip for forward slip and sideways slip. The important part comes here. If integration is disabled, the current slip value jumps directly to the target. But if integration is enabled, the value only moves toward the target, step by step. The coefficient controls how fast this happens. At very low slip speed, the change is small. When the wheel starts moving more, the response becomes faster. At the end, these integrated slip values are multiplied by the maximum tire force. Then the final forward and sideways forces are applied at the wheel contact point. So the code still uses the same slip model, but the force now builds up over time instead of snapping in immediately. This was a lot of work to put together. It took me almost 2 years of testing, rebuilding, and trying different ideas until I reached this result. Of course, this is not the only way to build a vehicle tire model in Unity. There are many other ways to solve the same problems, but for now, I am really happy with how this version behaves. If you have questions, ideas, or a different approach, feel free to write it in the comments. I would really like to hear how other people solve this. Unfortunately, this is a very niche topic, and videos like this are often not shown to many people by the algorithm. So if this helped you, liking the video or leaving a comment would really help a lot.